So let's see how some exponential functions can relate to the real world and in specific compound interest. If P dollars are deposited into an account and paying an annual rate of interest R, so that's going to be our R, compounded N times per year, after T years, the account will contain these A amount of dollars. So here is our formula for compound interest. Okay, so we want to find the future value and interest earned if this is the money we invest for 6 years at 5% and they compound it semi-annually. Okay, so I jotted down our P represents our principal amount, which is the amount you start with. The R is the rate, and you want to write it as a decimal. The N is how many times per year it's compounded, and our T is time. So semi-annually just means that our N is going to be 2. Let me write that down. Semi-annually means our N is going to be 2. 2 times a year. Now if I have my formula, A is equal to P1 plus Rn to the Tn. I write my formula down, and you need to be familiar with this. It says how much will you have when we start with that $7,458.65. That's our P. Parenthesis 1 plus our rate is 5%, which as a decimal, when you write a percent as a decimal, you move it 2 places to the left, so that actually becomes 0.05 over, we're looking for our N, and we said our N is 2 because it was semi-annually. The time, T is 6 years, so 6 times N, which our N is 2. Now the thing we have to be careful with is how we put this in the calculator. Some people do well with putting this all in the calculator all at one time, but I would suggest that you do 0.5 divided by 2, hit enter, add 1, hit enter, raise this answer to the 12th power, hit enter, and then multiply that times $7,458.65 for a total of this value. So I want you to be able to test that in your calculator, because the hard part's not necessarily plugging in all of our missing information and solving for what's left, but most often people struggle with actually putting this in the calculator. Alright, so the only difference in this entire problem is they say quarterly, which quarterly means our N is how many times a year, which quarterly would mean our N is 4 times. So A equals, I write my original problem down, my original formula. And then now we're looking for A, and our principal is the same, $7,458.65. 1 plus our rate is still the same, 0.05. The only thing different in this problem is our N. This time our N is 4 because it was compounded quarterly. Time is 6 years, and our N is 4. So let's talk about how to put this in the calculator again. Like I said, if you want to try it all across and you put enough parentheses and do it correctly, it can be done, but to break it down into parts, put 0.05 divided by 4, hit enter, plus 1, enter. Raise it to the 24th power, hit enter, and then multiply it last to the 7,000, and we should get A is equal to $10,049.42. So we can see just the difference right there. Not an extreme difference, but if they compound it semi-annually, twice a year, versus if they compound your value at 4 times a year, you can see there is a little bit difference, a little bit of a difference there. And now let's compare that to monthly. Okay, what would our N be for monthly? Good. N would be 12. Very good. And so we're going to just go ahead and do likewise. Write our initial formula. Okay, that's rewriting your formula every time will help you memorize your formulas that you need for um, taking tests. So don't skip that step right there, even though we're just wrote it above a couple of times. So we have 1 plus our rate is 0.05. In this particular problem, the only thing that's changing is our n value. Our time is 6, and our n is 12. So in the calculator, 0.05 divided by 12, enter, plus 1, enter, raised to the 72nd power, hit enter, multiply it times this, and we should get the calculation of $10,061.85. So 2 times a year, 4 times a year, 12 times a year. You can see that it benefits when it's calculated more frequently, when it's compounded more frequently. And now we look at the number E and continuous compounding. More often interest is compounded within a given time period, and interest is earned. There's a continuous compounding going on, which we're going to experiment with that down here. But before we start, we're going to look at this value of E. If in your calculator you hit E, or maybe even sometimes E to the first power, you're going to get this value, this long decimal value. It's approximately 2.72. So we use that when we have a continuous compounding, something that compounds over and over and over again. So let's see how this formula plays out with our investment. Number 5, the future value and interest, find the future value and interest earned. If we have $5,280, invest it, let's name it, that's our P, invest it at a rate, which remember we write a rate as a decimal, moving it 2 places, so it's 0.048 as a decimal, and compound it quarterly for 6 years. Well, quarterly means n equals 4, and our 6 is t. So we kind of jot down some of our variables as we go. So if we're going to compound quarterly for 6 years, we take our formula that we just used, P 1 plus R over N, T to the N, previous formula. Our principal this time is 5,280. Our rate is 0.048. N is 4. T is 6. So let's put this in our calculator. We'd say 0.048 divided by 4, hit enter, plus 1, enter, raised to the 24th power, enter, times 5,280, and our amount is $7,030.18. Make sure you get these values in your calculator. If I'm going too fast, pause it, take a minute, jot this down, and put it in your calculator and test that value. Alright, now let's see the difference when it says compound continuously. When you see this keyword, that's when you know we use this A equals P e to the RT formula up here. So A equals P e to the RT. P is just 5,280. E is actually a number, so we leave it E. R is 0.048, And our T this time is going to be 10 years. So if this thing compounds continuously over and over and over again for 10 years, we'll see that you're going to put e raised to multiply this out first and e raised to this value times 5,280. So that's going to be $8,532.87. Okay, you can see the difference. This was quarterly for 6 years, and then continuously for 10 years. You can compare the two. Okay, so pause this. I named P, I named my rate, my M for semiannually, and my time T. I wrote my original formula down, and now I'm going to substitute those values in. When I put those values in, I'm going to say 0.04, divide by 2, enter, plus 1, enter, raised to the 20th power, enter, times 2,500, and you should get this value. How much was raised over, how much interest is earned over a 10-year period? You would take your original and subtract it from what you got here to get that, and I'll do that now. So if you take how much your total was after the interest was earned and subtract the initial amount that you started with, this is the actual amount of interest earned over that time period.